this. So one dimension of the quality. Now we try to understand at least that what is the quality, what is needed in the software quality. So the quality, performance quality. So here the David discussed that software deliver all content, functions, features that are specified in the requirement model in a way that provide value to the end user. So if you have answered yes for all of them, yes, and when you say yes, you're very confident, that means you have a high quality. So say the performance of the quality. Not here, we are not looking at the performance of the software, but performance of the quality. That if you have all the user requirements and functions which were initially or changed in the requirements from the customer's perspective, then your performance of your quality is high. The feature, does the software provide features that surprise and delight first time an end user? Say the performance is what customer said, you did it. And the features, you added functionalities or added things in it. Surprised, like that, say customer was not expecting it. And reliability, overall, does the software deliver all the functionalities without failure? Or even if failure happens, how do you recover from the failure? Say, is it available when it is needed? Say, your software crashes, or your software goes in some inconsistent state, but can you recover from that crash? How quickly you can do it? Or does it deliver the functionality that is error-free? So reliability encompasses the functionality, proper functionality, correct working, but availability too. And availability doesn't mean that you need to have 100% availability. If it's 99 point or 98 or 99% availability is normally considered as high quality, or 95 or 97. So conformance, then does the software conform to local? Then you see when you develop a software that is used for a specific context, and that context is whether it's a business or it's for productivity or whatever it is, then you have certain regulatory requirements from that sector, or the government requirements, or any those sort of requirements. Is it conforming with all of them, local external standards? And does it conform to, say, de facto design or coding conventions? For example, in the coding, you write your code in a way that is very difficult to understand, and you have a unique way of writing the code. Maybe it's correct, but it's not easy to understand for the other coders or the testers. So in that code perspective, or you have created the user interface which is using all the new controls which no one has used. So maybe it's something good unless you prove that it is correct, but maybe it's better that if you use what is being used currently, say input of the text. When you get an input, there can be different ways of getting an input. Somewhere where you know that the inputs are predictable, then there you don't want users to type. You can have that drop-down list. People can select from that. But if the input is unpredictable, you can always put a text box, or the menu selection, or different visual buttons that, or the controls that you put on the user interface. You don't want to have more surprises that users see what is this. The menu style is completely different. So just go what is in the practice, what is widely used in that area. The quality dimension 2, say, so here, see, we are looking at the performance of the qualities and user. If it is needed, it's there, it's good. The feature of the quality, something new. which even user didn't ask, but you have some additional features. And reliability, correctly work. If it crashes or if there is some problem, then recoverability should be quick. And conformance with the regulatory authorities, standards, internal, external standards, and the user interfaces specifically. So then durability can be maintained and corrected. Say, if you create a software product and something goes wrong in it, can we fix it or add something, the serviceability, or later we also, in durability, we also look at the modifiability too. But that is later. This is just this view of David that he's providing in the quality dimension. Then these attributes are expanded more in later standards, as we see. But normally modifiability is in durability. Say if there is a change, can we do it? Can we, or is it achievable? Or you can't change anything. It's fixed, rigid. Whatever you have is correct or wrong. It's there. And serviceability, software maintained. If we need, say, changes in the design itself, you want to add more functionality into it, can we achieve it? So if we have these characteristics, that means it's a quality software. And then aesthetics. Now, aesthetic, we can't really measure the aesthetics in the software, but somehow you can see that it is very, aesthetic is normally related to the usefulness of the software. So you create a screen and you don't have the menus, and you just have one single icon, and all of your menus go from that icon. You can see that you cannot measure it whether this is good or bad, but you can see that people are familiar with the menus that nowadays we have. You have a bar at the top, and you have drop-down menus that quickly they can see, and people know that how to use it, but you come up with something new, which is very obscure, and to use it. So, or say, I mean, generally aesthetics are with the elegance or unique flow or obvious presence. So all these things that you can observe yourself. And perception, in some situations, a set of prejudices that we have, then perception of the quality. So we don't come up with our perception and we just have, this is what we think. We have our own belief system. This is what the quality is. So you just put what you think is the quality. Well, we have to be adaptive and see if we can improve the quality. Right, so that's just the David Garvin's initial suggestions for the quality. Now, McCall's and Walter, they propose a useful categorization of factors that affect the software quality. And after this, many of these characteristics that we have, or the attributes that we have, they are in the ISO standard too. But this was really the, you can call it the basis from which the standard has emerged. So starting from, so what it has, we have the product operation, transition, and revision. So if we try to see it, three different views in a pyramid. So when we are looking at the operation, well, we have them on next slide where we have the all text, but it makes more sense if we explain or look at them from these different sides of a pyramid. So say when you produce the software quality, or you are in a process of producing the software, so you look at the correctness. So correctness is the functionality that we say that whatever you are creating, all the functions, all the tasks that need to be done correctly as was in the requirements. And in the reliability, we not only look at that the task is being done and task is done in a specified time if there are time constraints, and is your software is available when user wants to use it, or 50% of the time when you want to use it, it's always in maintenance or it's always crashed. So here in the reliability, we also measure the availability time.
The Victorian Institute of Technology has other great videos covering many different topics. Please check them out, and thanks for watching. Remember to like and subscribe the video for more great content like this.